Alright, so today we are going to talk about squares and square roots, also known as exponents. Exponents, well, we'll get into it a little bit, but we are going to focus on square roots. But in order to understand a square root, you have to understand a square. So many of you have already learned squares, which is great, but square roots are often done using a calculator, and we're going to practice square roots without a calculator. And the reason why we practice square roots without a calculator is because it's another way of understanding why the mathematics work, why we do what we do, and we're just going to use the same method that we've used to break down prime numbers or use prime factorization. So I'm going to go ahead and get started with some vocabulary, and then I'll show you how to break a square root down. Alright, so with an exponent, there are two important things that you need to know. The first is a base. And the base is the number being multiplied in an exponent. It is the number being multiplied in an exponent. The exponent is also known as a power. It tells how many times multiply the base. So you have a base number with an exponent. The base number is the one you multiply. The exponent tells how many times you do that. So here is our example. Three to the power of 4. 3 is our base number. 4 is our exponent. It means 3 times 3 times 3 times 3. It does not mean 3 times 4. The mistake that I see the most with exponents is thinking that 3 to the power of 4 means 3 times 4. And these mistakes will happen all the time. So you need to be very precise in remembering what an exponent is. Alright, so that's the basics of an exponent. Now we're going to go into square. A square means you multiply the number by itself. You use the power of 2, or the exponent 2. So I'm going to say I have a number. It can be any number, and I'm going to call that number x. Here's where algebra comes in a little bit. X stands for any number, and then I square it. And that means x times x. And this little dot here is a multiplication sign. And as we get into more algebra, especially closer to the end of the year, we're going to stop using the multiplication sign, because that's how what algebra looks like. Sometimes we'll use a little dot, and sometimes we won't use anything at all. And you'll get to know that a little bit better as we go into more algebra solving closer to the spring. So another example of a square would be 5 squared, which means 5 times 5. Here we could use the multiplication sign because we have two numbers. We don't use the multiplication sign when we use algebra or letters because it would look like XXX, and that is very confusing. The word square comes from the actual square, an actual square. Because we know that a square has all sides that are the same, in order to find the area, it's going to be 5 times 5, which gives us 25. And because we're multiplying that number twice, that same number, it gives us 5 squared. And that means this whole part here, the area, 5 times 5. Okay, so a square root is the opposite of a perfect square, which I'm going to define next. And we use the sign, I think it's called a radicand, but this is the sign for a square. So, perfect square and there was a question on your one of your work last week with the it was factors, it was the tasks that you did on Nearpod, and it had a question about perfect squares. And they only had 3 factors. The perfect squares only had 3 factors. Okay, a perfect square is the product. The product, remember, is the answer to a multiplication problem. The product to the square of a whole number. And it has to be a whole number. So, 25 is the perfect square because it's the answer to 5 times 5. We've got 2 times 2, which is 4. 4 is a perfect square. We've got 3 times 3, which is 9. 9 is a perfect square. We have 4 times 4, which is 16. 16 is a perfect square. 5 times 5, which is 25. 25 is a perfect square. And so on and so forth. Okay? So I need to flip my paper over because you know I write largely and I'm out of room. Our example here is 10 squared equals 10 times 10. Ten times 10 equals 100. 100 is our perfect square. And so we're going to take the perfect square, we're going to make it into a square root. In our radicand. I'm pretty sure it's called the radicand, but if you want to look it up, you can look it up. And then the answer to that perfect square is 10. And so 10 is the square root of 100. And we know that because 10 is the square root of 100, that 10 times 10 is the square. 10 squared. All right. So I gave you some other perfect squares. And so we'll now find answers. Okay, so, well, actually, let's write them down. Other perfect squares are 4, 9, 16, we had 25, 36, 49, skip, 81, right? So this is 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7. I skipped 8 times 8 and went to 9 times 9. And then the square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 36 is 6. Alright, so now what we're going to do is we're going to look at some perfect squares. And we're going to figure out how to find a perfect square root without a calculator. And these will be bigger numbers. Okay? So I'm going to tell you that 196 is a perfect square. So a number times a number equals 196. This is how we find out what that number is. We're going to find the square root of 196. And in order to do that, we are going to use prime factors first. You already learned how to break down numbers using prime factors. If you need to go back and look at your notes that tell you about prime factors, go ahead and pause and do that now. We have our sieve of Eratosthenes that has a list of prime factors. We're going back to that basic thing. So I'm going to put 196 into my ladder. And if you want to use the tree method, you use the tree method. I already told you that one is confusing to me. So we're going to use prime factors first and only. And the reason why we do that is because we're going to have to make two groups at the end. Alright, so first let's start with breaking this down. 196 is divisible by 2, and I know that because it ends in 6. So 2 does not go into 1. 2 goes into 19. 9 times, which gives me 18. 9 times 2 is 18, which means I have 1 left over. 2 goes into 16, 8 times. Nothing left over. You can't have leftovers here. Alright, 8 is even, so I use 2 again. 2 goes into 9 4 times with 1 left over, because 4 times 2 is 8. So I put that 1 little left over here. Now I do 2 into 18. 2 goes into 18 9 times. 49. 49 is divisible by 7. 7 is a prime number. 7 goes into 49 7 times. I'm almost done. 7 goes into 7 1 time. I have my 1. Do you remember this? We get down to the 1 for prime factorization. Same thing with square root. Okay, now I know that 196 is 2 times 2 times 7 times 7. But now what I want to do is I want to take these numbers and I want to form two groups evenly. Okay, so I have 4 numbers here. That means I'm going to have 2 numbers in each group. Here's group 1, here's group 2. I'm going to put them with parentheses because parentheses indicate their groups. I have a 2 here, I'll put it here. I have a 2 here, I'm going to put it over here. A 7 here and a 7 here. I can't put 2 times 2 and 7 times 7 because those two groups won't be even. Has to have the same numbers. These have to be the identical groups. These two groups have to match. And the reason they have to match is because whatever I get has to be the same. And the reason it has to be the same is because that is going to be my square root. 14 times 14 is 196. Therefore, the square root of 196 is 14. Fourteen times 14 is 196. The square root of 196 is 14. Alright, so I'm going to give you, we're going to practice this for sure, okay? But I'm going to give you a to-do that we already know the answer to, but that you're going to prove it by making groups, by doing this method. Okay? So, prove the square root of 100 is 10. So you're going to break 100 down. You're going to make your two groups, and those two groups will equal 10 times 10. Okay? That's your to-do. And we'll correct it on Tuesday morning.